Alright, so we've been talking about ionic radius and how ions form in an ionic compound and how those varying sizes depend on the electrons involved and the nuclear charge and also how many energy shells there are. So just as a reminder, when we are looking at any of our cations, when cations form, and it's always going to be this darker shade right here, when cations form like lithium, it loses electrons, or it's transferring those electrons. And so when a neutral atom of lithium loses or transfers that one electron, the overall ionic radius is going to be smaller than its neutral parent because the nuclear charge, or the proton amount, is still pretty high, and it's going to pull the remaining electrons closer together, creating a smaller ionic radius. Whereas when I'm looking at anions are going to get larger. So if I look at oxygen's neutral atom and it gains 2 electrons, the radius is going to get larger because there's more electrons to repel each other, pushing further apart, creating a larger radius. And so then we talked about an isoelectronic series. So let's put that in your notes right here. Remember, an isoelectronic ion is atoms with the same electron number. And so when we see these isoelectronic series, they are going to be based off of the atomic number or the nuclear charge when determining their size. And so basically, the higher the atomic number or higher the amount of protons, the smaller it's going to be because there's more protons pulling in the electrons. So let's look at some examples. It says arrange the following in order of an increasing ionic radius. So when we are looking at our periodic table, we have nitrogen here, we have magnesium, and we have neon and fluorine. So all of them are going to look like neon here. Okay, so all of them have the same electron amount. So that means that we are going to use the isoelectronic series rule and know that the highest proton number is going to be the smallest. So magnesium has the highest atomic number or proton number, so that means magnesium is going to be the smallest, and then it increases to neon, which has the second largest atomic number, and then it goes to fluorine, and nitrogen has the smallest atomic number, so it is going to be the largest in size. Now, when we look at ions in the same group, they are not considered isoelectronic series, but they have the same charge, which is also a deciding factor on size. We can compare them based off of how many energy levels or how many energy shells they have. So I have sodium, lithium, potassium, and cesium. So as we move down a group, we are going to see that it's going to get larger in radius size because we're adding energy levels. So that means that we are going to have lithium first, and then we are going to have sodium, and then potassium, and then cesium. Okay? And so with that, there are 2 rules you follow. If they all have the same electrons, then the one with the highest atomic number is going to be the smallest in size. And then, of course, we have any set of elements in the same group with the same charge. We're going to see that the one with the smallest energy level, or the one in the smallest energy level, or the one with the least energy shells is going to be the smallest, and then it increases as we go down.